Do an application here. So we're going to talk about work. The work W done by a force F, moving an object from A to B is given by the following formula. So work is the dot product of the vector for force and the vector that goes from A to B. So this formula is correct. Or remember, we have an alternative formula, which is sometimes more helpful if you're dealing with angles. So the formula for that would be the magnitude of the force times the magnitude of the vector from A to B multiplied by the cosine of theta. And theta is the angle between the force and the direction of motion. So whatever direction you're moving in. So for example, let's say there is a child that is pulling a sled along level ground, so flat ground, and they're exerting a force of 30 pounds on a rope that makes an angle of 35 degrees with the horizontal. So here's my terrible picture. So here's a child, and here's their sled, just like an old-fashioned sled there. And maybe their younger sibling is on board. This is what I think of with my kids, someone pulling like the little baby along or the toddler. So there's a force of 30 pounds on the rope, and the older child is holding the rope here. So what happens is you have an angle of 35 degrees with the horizontal of that rope. And we want to know how much work is done by pulling the sled 200 feet. So our formula here, and the one we're going to use is the second one here because we have an angle. So if we don't already have the vectors, and we have the angle, then that's the one that you're probably going to want to use. So for the first one, the magnitude of the force is 30, right? Because the force is 30 pounds. Now, the second one is actually easier as well because you're pulling it 200 feet. So the length of that vector would be 200 feet. So that is the magnitude there as well. So 200. And then you're looking at cosine, and our angle is 35 degrees. Now, this is one that you can use your calculator on. Make sure you're in degree mode before you use your calculator. And when you multiply this all out and you round, you get about 4,900. So thus, the work done is about 4,915. And the units there would be foot pounds because we're traveling in feet and the force is given in pounds. So just a quick application there. Using our vectors again and using the different forms of the dot product formula.